Hi, I am Dr. K.V. Raghavulu, working as Associate Professor in Department of Mechanical Engineering, Marri Laxman Institute of Technology and Management. So today I'll be discussing basic concepts of thermodynamics. So in the first module, I'll be discussing introduction part, an application part, and system surroundings and boundary, and types of systems, macroscopic and microscopic view analysis, and state, path, process, and cycle, and properties and types, and the thermodynamic equilibrium. So before going to start the concepts, we should aware of a few important terms which are frequently used in this subject. They are temperature, heat, and specific heat. And one more term is work. So temperature means it's a measuring of kinetic energy of the particles in a substance. So simply I can say that it's a measure of hotness or coldness of a body. So heat means it's a form of energy which will transfer from one body to another body due to the temperature difference. Suppose I am taking two bodies or two parts. So first body temperature is 10 degrees centigrade and second part temperature is 5 degrees centigrade. And transfer of energy from this 10 degrees to 5 degrees is called as heat. And one more term is specific heat. Specific heat means the amount of heat required to rise 1 kg of substance into 1 degree temperature difference. Suppose I'm taking any substance which is having 1 kg and the substance temperature is 10 degrees centigrade. I want to increase the substance temperature from 10 to 11 degrees centigrade. I have to give some amount of heat. That heat is called as a specific heat. So specific heat units kilojoules per kg Kelvin, and heat units kilojoules, joules, and temperature units degrees centigrades or Fahrenheit or Kelvin. And one more term frequently we are using in this subject, work. So work means a force into a distance moved by a body in a same direction, or displacement. For example, this is the one body. I am applying some force on this body, and this body moving from this point to another point, and the distance is x. So now work equals to F into x. So these are the terms which are used frequently in this subject. Next, coming to the subject, thermodynamics. So thermodynamics is a Greek word. So thermo means heat, dynamics means power. So definition point of view, thermodynamics means it's a branch of science which deals with the conversion of one form of energy into the another form of energy. So simply heat into the work or work into the heat. Suppose if we supply heat input to the system, then we will be getting work output from the system. So vice versa also. So we'll discuss a few thermodynamics applications. First one is internal combustion engines. So in internal combustion engines, we have petrol engines and diesel engines, etc. So if we consider a piston cylinder arrangement, so this is a piston cylinder arrangement, inlet valve and exhaust valve. This is piston. And this is cylinder. If it is a diesel engine, we'll be having a fuel injector. This is inlet valve and this is exhaust valve. So we have 4 stroke: suction stroke, compression stroke, expansion stroke, exhaust stroke. In a suction stroke, if it is diesel engine, air enters into the engine cylinder, and in a compression stroke, air is being compressed. At the end of the compression stroke, fuel is injected with the help of a fuel injector. Then due to the compression ignition, fuel burns and produces the heat energy, and because of this heat energy, piston heating into the downward direction and produces the work. So here concept is we are giving heat input and produces the work output. So conversion of heat into the work. So discussing this behavior is called as thermodynamics. And one more example, boilers. So boiler is a device which is used to produce the heat energy. I'm taking a simple boiler which is filled with some quantity of water, and I'm supplying heat input to the boiler and produces the steam. So by taking this steam, and rotates the turbine and produces the work output. So now here I'm giving heat input to the boiler and produces the work output from the turbine. Again, heat energy is converted into the mechanical work. So again, this discussing this thing is called as thermodynamics. And one more example, gas turbine. Gas turbine cycle. So in a gas turbine cycle, this is a compressor, and which is used to compress the air. Initially, we are sending air input, air to the compressor and compress the air. And this is combustion chamber where the fuel is injected, and burning the fuel produces the hot gases, and these hot gases are ascending into the turbine and produces the mechanical work. So here also we are giving heat input and produces the work output from the system. So this is again discussing this thing is called as thermodynamics. So here in all these three applications, heat energy is converted into the mechanical work. If we consider a refrigerator, one more example, refrigerator. So in a refrigerator, mechanical work is converted into the heat energy. I'll explain with the help of line diagram. So this is a compressor, and this is condenser, and this is expansion valve, and this is evaporator. 2, 3, 3 to 4. So here we are giving compressor work, and with the help of this work, receiving heat from the evaporator. So in this cycle, vapor compression cycle, in refrigerators and air conditioners, we are using vapor compression cycle. So in this, initially refrigerant enters into the evaporator and absorbs the heat from the evaporator. So then refrigerant converts into the liquid refrigerant converts into the vapor. Then this vapor is sending into the compressor and compress the vapor. Then that is the reason this cycle is called as vapor compression cycle. Then it is sending into the condenser where the heat rejection takes place. Then it is sending into the expansion valve. Here decreases the pressure and temperature. Again the cycle is repeated. So here the concept is we are giving work input to the compressor and receiving heat from the evaporator, abstracting the heat from the evaporator. So here work is converted into the heat energy. So discussing this thing is called as thermodynamics. So heat energy is converted into the mechanical work, and mechanical energy is converted into the heat energy. So this is called as thermodynamics. Next, coming to the basic concepts point of view, the first one is system. So system means the region in a space whose behavior is investigated. So I'm taking a piston cylinder arrangement. So this is piston cylinder arrangement. So in this piston cylinder arrangement, this is inlet valve, and this is exhaust valve, and this is a fuel injector. Here heat energy is converted into the mechanical energy. So I am taking this area for the thermodynamic investigation. Then now this is called as my system. So anything other than the system is called as surroundings. So this is surroundings and this is system. The separation between system and surroundings is called as boundary. So generally boundaries are two types: imaginary boundaries and imaginary or movable boundaries and fixed boundaries. So coming to the types of systems, there are three types of systems. One is a closed system, another one is a open system, and third one is a isolated system. In a closed system, there is a fixed quantity of mass and energy transfer across the boundary. So all these systems are categorized based on the mass and energy. Suppose if I take 1 kg of fuel, 1 kg of fuel, then this is called as mass. When the fuel gets combust and produces the gas or produces the heat energy, then that is called, produces the heat, then that is called as energy. So here, based on this mass and energy, so systems are classified into three types: closed system, open system, and isolated system. So in a closed system, the mass is fixed. We cannot change the mass, and only energy transfer across the boundary. The best example is a cup of coffee in a flask. So in this example, the coffee is filled and cap also arranged, tightening the cap. So here in this example, the mass of coffee is fixed. We cannot change the mass of coffee, and heat energy transfer from the system to the surroundings. So here mass is fixed and energy transfer from the system to the surroundings. So this is called as a closed system. So one more example, if I consider a piston cylinder arrangement, so this is inlet valve and this is exhaust valve and this is fuel injector. So here this is the fuel, and due to this fuel gets burned and produces the mechanical work. So here because of this heat energy, that piston moves into the downward direction. So here the mass of the fuel is fixed. If it is a closed system, means we don't have any walls. So mass of the gas is fixed and piston moves into the downward direction. So this is called as a closed system. Then coming to the open system, both mass transfer and energy transfer from the system. So in this example, we don't have any cap on the coffee cup. So here the mass of the coffee is fixed and heat energy transfer from the system to the surroundings. So mass transfer is there from the system to the surroundings and energy transfer from the system to the surroundings. So now this is called as open system. So same example in a piston cylinder arrangement, if we consider the walls, inlet valve and exhaust valve, then the mass enters into the system and energy transfer from the system. This is called as a open system. In the piston cylinder arrangement, if you don't have any walls, so mass of the system is fixed and only energy transfer from the system to the surroundings, then it is called as a closed system. So closed system means there is a fixed quantity of mass, only energy transfer across the boundary. So open system means both mass transfer and energy transfer across the boundary. Coming to the isolated system, so neither mass nor energy across the boundary. So no mass transfer and no energy transfer across the boundary. So in the same example, it is a well insulated flask, coffee in a well insulated flask. So here mass of the coffee is fixed and we don't have any energy transfer from the system to the surroundings. So no mass transfer and no energy transfer across the boundary, then it is called as isolated system. Next, coming to the another topic, macroscopic and microscopic view analysis. So name itself it is mentioned, macro means very big and micro means it's a small thing, small analysis. So microscopic means consider the behavior of individual molecules. So macroscopic means consider the behavior of average molecules. So the macroscopic analysis also called as classical thermodynamics and microscopic analysis also called as statistical thermodynamics. Because in a microscopic analysis, it involves more number of equations, more number of mathematical formulas, and it is very difficult analysis. But whereas in a classical thermodynamics or macroscopic analysis, it involves very less formulas and it very easy to analyze the properties. So this is called as macroscopic analysis. Very less number of equations or properties are required in this macroscopic analysis. For example, if I want to measure the area of this room, so simply I'll take length and simply I will take width. So multiply this length and width is called as area, then we'll get this is called as macroscopic analysis. Coming to the microscopic analysis, we'll consider the behavior of individual molecules and measure the area of this triangle, then this rectangle, then that is called as a microscopic view analysis. Generally in our day-to-day life, we are using macroscopic analysis only. Measuring the temperature is a macroscopic analysis, pressure measurement is a macroscopic analysis, volume measurement is a macroscopic analysis. So very special cases we are using microscopic analysis. But only one biggest advantages in microscopic analysis is it is a very accurate than the macroscopic analysis. Then coming to the next topic, state, process, path and cycle. State means condition of a system. Suppose I am taking a piston cylinder arrangement. Piston moves from top dead center to bottom dead center. So this is called as initial condition and this is called as final condition. So this initial condition is called as state, initial state, and final condition is called as final state. So the change of state is called as process. So state means condition of your system and change of state is called as a process. So change of state in a particular direction, for example, a process means this is one state and this is another state. So change of state is called as process. But change of state after considering few intermediate states, then this is called as path. But in a process, we will consider the initial condition and final condition only. We are not considering the intermediate states. Then coming to the cycle, the initial state and final state of your system is same, then that is called as cycle. So this is one process and this is another process. So combination of more than one process also called as cycle. But the thing is, initial state and final state should be same. So this is a 2 process cycle and this is 3 process cycle and this is 4 process cycle. This is 5 process cycle. So this is called as Otto cycle and this is called as a diesel cycle. So 1 to 2, 2 to 3 and 3 to 4. This is a PV diagram. And this is also a PV diagram. 1 to 2, 2 to 3, 3 to 4 and 4 to 5 and 5 to 6. So this is called as Otto cycle and this is called as a diesel cycle. The initial state and final state of a system is same, then that is called as thermodynamic cycle. Then coming to the properties. So properties means any measurable characteristics of a system is called as property. Properties are classified into 2 types. One is intensive properties and another one is extensive properties. So intensive properties means a property which is independent upon a mass of a system. So extensive properties means property which depends upon a mass of a system. If we consider a few properties like temperature. Temperature is not depending upon a mass. Then pressure is not depending upon a mass. So these are called as intensive properties. The density is not depending upon a mass. This is also called as intensive properties. So properties are depending upon a mass of your system are called as extensive properties. For example, if this is one area and this is divided into 2 parts. So now if I take a mass is divided into 2 parts. So m by 2, here half kgs, suppose if I take 1 kg, this is here is half and here is half kg. And volume also, if I consider a 1 meter cube, here it is 1 meter cube, then here it is a half meter cube and here it is half meter cube. But temperature at this chamber and at this chamber, temperature is same. So here also pressure is same. So temperature, pressure and density, these are the intensive properties, and mass and volumes are extensive properties. And one more thing, there is one condition, the ratio of 2 extensive properties are called as intensive properties. For example, density equals to mass by volume. So the ratio of mass and volume is called as density. And a specific extensive properties also called as intensive properties. For example, volume is a extensive property, specific volume is a intensive property. Similarly, enthalpy is a extensive property, specific enthalpy is a intensive property. So property depends on a mass of a system called as extensive property. So properties are independent upon a mass of a system are called as intensive properties. Next, coming to the thermodynamic equilibrium. So equilibrium means same or equal. So thermodynamic equilibrium means if 2 systems are said to be thermodynamic equilibrium and they should satisfy mechanical equilibrium, thermal equilibrium and chemical equilibrium. So if these 2 systems are satisfied with these 3 equilibriums, then only it is called as thermodynamic equilibrium. Otherwise, it is not a thermodynamic equilibrium. So first I'll discuss mechanical equilibrium. So mechanical equilibrium means we will say that equality of the forces. So here in this diagram, the upward force and downward force of a system is same, then that is called as mechanical equilibrium. Then coming to the thermal equilibrium, so we can say that equality of the temperature. I am taking 2 bodies. First body temperature is 0 degrees centigrade and second body temperature is 100 degrees centigrade. If I combine together, after some time, these 2 bodies temperature is same, that is 50 degrees centigrade. Then it is called as thermal equilibrium. Then one more thing is chemical equilibrium. So chemical equilibrium means if you consider 2 or more substances, if we don't have any chemical reactions inside the system, then that is called as a chemical equilibrium. So if the system is said to be thermodynamic equilibrium, it should satisfy all these equilibriums: mechanical equilibrium, thermal equilibrium, and a chemical equilibrium. Then only it is called as thermodynamic equilibrium. If any one equilibrium is not satisfied, then that is not a thermodynamic equilibrium. Next one is quasi-static process. So quasi-static process means it is a very slow process. I'll explain with the help of diagram. So this is a piston cylinder arrangement. So in this piston cylinder arrangement, I'm keeping a weight. Then this piston moves from top dead center to bottom dead center. So at this case, this is the PV diagram 1 to 2. So if it is moving from top dead center to bottom dead center, then this is called as a compression process. So in this compression process, so PV diagram is like this. Pressure in a compression process, pressure increases and volume decreases. So here pressure increases and volume decreases. So here this total weight is divided into infinite number of small weights. Infinite number of small weights. Then if I keep one weight on the piston, then the piston moves 1 point to this point, then one more this point, this point, this point, this point, this point, like this. If I draw this curve, it will be getting like this. Then if I remove the pistons, then if I remove these pistons, these weights one by one slowly, then expansion takes place. So in expansion process, this curve is looking like this. Then this process is called as quasi-static process. So in a quasi-static process, we should maintain the uniform properties like pressure and temperature and volume uniform throughout the system. Then only it is called as quasi-static process. So if suppose if I remove the weight suddenly, then there will be a unbalanced force acting on your system, then that is not a quasi-static process. If I remove the weights slowly one by one, then piston moves slowly, then it will maintain the uniform properties, then that is called as the quasi-static process. If I put the weights on the piston slowly one by one, then it will maintain the constant properties, then also this is called as a quasi-static process. Otherwise it is not a quasi-static process. Then coming to the reversible process and irreversible process. So reversible process means forward path and reversed path of a system is same, then it is called as reversible process. The forward path and reversed path of a system is not same, then it is called as irreversible process. I'll explain with the help of real life examples. So in this example, I am taking 3 ice cubes. Then if I melt the ice cubes, then ice converts into the water. Then again in a reversed process, then if I freeze the water, then I will get the ice cubes also. This is called as reversible process. And the second case, in a irreversible process, if I take an egg, if I break the egg, then reverse position is not possible to frame a new egg. So this is called as irreversible process. Again, reversed process is not possible. Then one more example for irreversible process: formation of curd from the milk. So once if I form the curd from the milk, and the reversed process is not possible. So curd to milk is not possible. Then breaking of glass. So this is a glass, I break the glass, then this glass to original glass is not possible. And growth example also. So these are called as irreversible process. So once it happened, it is impossible to get it again. But in the case of reversible process, we will get it again. So in the case of thermodynamic examples, Carnot cycle and isothermal expansion and compression, adiabatic expansion and compression, these are all under reversible process.